So, hello student. So, today again we will go for another lecture on collection of solid waste. Until now we discussed about the different collection services, collection system, especially the hall container system and stationary container system. Also we discussed about different parameters in stationary and hall container systems. I think another lecture also will discuss how to compare both these different collection system. But before that we will go for analysis of collection system. Here we will see the different equation, we will solve few numericals also and we will go one by one. First in the this is the part 1 lecture which is specially onto the hall container system, how best we can design the hall container system. So, this is analysis of hall collection system. Now, to establish vehicle and labor requirement for the various collection system and methods, the unit time required to perform on each task must be determined. This is the one of the very important parameter while designing or while establishing the number of vehicle required, number of labor required, number of manpower required. We required especially the unit time required to perform for each task, and there are different tasks under the collection which we will see in the further slide. And by separating the collection activity into unit operations, here we are saying the unit operations, it is possible to develop design data relationship between different unit operations. Universally also we can compare and also evaluate both variable associated with the collection activity and their variable relation to the particular location also we can see that. So, what are the different unit operations? There are 4 unit operations. First is the pickup, this is first operation, our time required, that pickup time. Another is the haul time or haul unit operation, 8 site and off route. So, one by one we will discuss all the 4 unit operation under the hall collection system. So, before going to the different unit operations, I just want to show one more time how this hall container system will work, okay, which I already showed in the first lecture on collection systems. But again you see that the beginning of daily route from the dispatch center, it will go to the first location, it will take the full container, pick up loaded container and it will travel to the transfer station or recycling facility or disposal site to haul loaded container along the vehicle with haul loaded container, and it will again go to the empty container in the same location, it will deposit the empty container. Similarly, it will go to the next location and again it will follow the same way of collection or operation until the nth location, and finally, it will end the daily route, okay, once the time will get over in a day. This is the one way. Another way where the vehicle will have one empty container, it will first deposit the empty container and same time it will load the full container and it will again continue with the another locations. It will deposit first the empty container and also pick up the loaded container in the same time. So, likewise it will go and finally route will get end or it will start to the new route. Now, we will see the one by one what are the different unit operation. So, you see here the first is the pickup time or that nominated by PHCS. Here HCS is a named as hall container system. Okay. So, now here this is what we see, that the flow of the vehicle in the different location. So, what will the pickup time or pickup unit operation, that picking up a loaded container. So, that is you see here PC, that we normally call as a PC, picking up the loaded container. Next is the redeposition of the container after it has been emptied, that is UC. This is UC. redeposition of empty container and driving to the next container after an empty container has been deposited. So, this is the DBC value. So, by sum of this all these 3 unit operation called pickup time or PSCS, it will call, that is PC plus UC plus DBC. So, the next functional unit operation is a haul, that is time required to reach the location where the waste will be emptied and starting when the container has been loaded on the truck and continue through unloading until the truck arrives at the location where the empty container is to be redeposited. So, in this case the haul time will get start when the unloading loading of full container until it will go to the disposal site or recycling facility and again it will go to the same location. This time required, that considered as a haul time, that is a unit operation, and it neither includes actual picking up of loaded container, redeposit of the empty container, nor the time spent at the location where the waste is unloaded. That is also not here also there also the time required for unloading of waste onto the disposal site or recycling facility, that is also not including into the haul time. Next is the at site time. This is the time spent at the site, that is the final where the waste is getting disposed of, that could be a landfill, MRF, material recovery facility or transportation where the system is unloaded. So, that time it also include the time spent waiting to unload as well as the time spent unloading the waste from the container or collection vehicle in the both the cases. So, you see here waste unloading from the vehicle is one of the vehicle, waste is getting unloaded. Now, next is the next unit operation is a off route, that is nominated as W. This refers the time spent on to all non-productive activity, the non-productive activity that typically used to be a 15%. And what are those? Many of these activity associated with the off route time are sometimes necessary or inherent in the operation, that is very important for the operation, that is necessary, and something could be a unnecessary also is possible. So, the necessary will be include time spent in check in, check out, meeting, breaks. So, whenever the vehicle is reaching to the disposal site recycling facility, it has to be check in, or somebody is writing, or you have to wait, that vehicle has to wait, maybe there are number of vehicles will be together. So, it has to be wait until their slot will come up for emptying the vehicle. Also time lost due to the unavoidable congestion, it is also possible that maybe because of traffic issue also is possible, and time spent onto equipment repair, maintenance, that is also possible. These are all necessary activities, necessary operations during the collection, and like you see here weighing of collection truck. Also wherever the vehicle is entering to the recycling facility, it is getting weighted. So, how much amount of waste is going inside the disposal site or recycling facility? It is also possible that one is coming out, again the weight is getting measured, and many times the vehicle is also get cleaned, because lot of if suppose that vehicle is collecting biological waste, obviously has to be clean every trip, or wherever is getting emptied, it has to be clean. So, for that there also it required time, that is a necessary time. So, here another photograph for the weighing of volume of each truck in the platform scale, and there could be some unnecessary, that is time spent in the personal or unnecessary extending the tea times, coffee breaks, and you know that few vehicles, few drivers will always do some unnecessary time they will spend. So, that is including into the off route. Now, we will go for the some equations for designing of Hall container system. So, the first is the time per trip. So, for one trip or for one location, how much time is required? That is normally is a sum of pickup time, sum of at site time and sum of haul time. That is a total time for the per trip. The time required for a trip is the sum of pickup time, at site time on site and the haul time. And this pickup time may be expressed, again this pickup time is expressed, that is a PC plus UC plus DBC, that is a pickup time, and that could be a different, for picking will be different, and for depositing empty container time will be required, transportation from one location to another location, that could be also different. So, this is the PC is time required to pick up loaded container, time required to pick up empty container, that is UC, and DBC time required to drive between container locations. So, here in this equation the PC we can calculate by PC plus UC plus DBC. Now, next is the pickup time, at site time. Even at site time is known, how much time will be required to empty the container at the disposal site or recycling facility are relatively constant, almost you know that how much time will be required in that case. But the haul time is depends on haul speed and distance. What is the distance from that particular location or from different locations, what is the distance, and also the speed is also important to find out the haul time. So, that haul time may be expressed is a function of round trip haul distance, that h equal to a plus b x. If you plot a graph between haul speed with haul distance, round trip haul distance, we will see here a rectangular parabola. See here, and here we see the speeds also, different speeds. So, from this we are getting the equation that for y equal to x divided by a plus b x, where a and b are both are haul speed constants. But you see here h is equal to x by y, that is a known things, that is a time, haul time is equal to round trip distance divided by haul speed. So, if you put it here in this equation, like here I am solving here, like if h is equal to x by y, then this x divided by, in case of y, this will be a x divided by a plus b x. So, this x will get cut and this will be a plus b x. So, that is what a plus b x we can find. Now, here the importance are the haul time constants a and another haul time constants, that is b, should be known. Now, here the another equation to calculate the number of trips, that is ND, that number of trips in a day, that normally find how much time available in a day. This is how much time available in a day and how much time required for one trip. By that way we can calculate the number of trips. Now, here you see here the time available in a day we calculated, like we minimize the off route time, that is HW, we minimize that W 15%, whatever the value is given of W, if not given we will assume the 15%, and also we minimize the T1 and T2, where this T1 and T2 are time required to drive between dispatch station from the garage to the first container, that is a T1, and T2 is time to drive between last container location to the dispatch station finally, that is T2, it is possible that that T2 and T2 could be negligible. Also is possible that because normally the first location we are finalizing which is very close to the dispatch center. So, in that case T1 could be very low value could be possible, and even T2 also that is also possible sometimes that dispatch station is very close to the disposal site. So, in that case T2 will be negligible. So, by that way we can calculate number of trips. Now, first we will go for first numerical to determine the Hall speed constants, which I told in the previous slide for calculation of A and B, how best we can calculate. The following average speeds were obtained from various round trip distance to a disposal site, and find the Hall speed constant A and B and round trip Hall time for site that is located 11 miles away. So, this is what data is already available with us. We know the round trip distance, different round trip distance, and we also know average speed, and also we know the total time is required, that is x by y we can do, and easily we can find the total time. So, now we have to calculate the constants A and B and round trip Hall time, that also we can calculate, that is x value. Now, the solution, we will go for solution. The basic Hall speed equation, that is we know that is a rectangular hyperbola, that is y equal to x by a plus b x. So, if you linearize this equation, we will get it h plus a plus b x after linearization, which we have seen in the previous slide. Now, if you plot whatever the data is given, the x and y, which is the total Hall travel time versus round trip Hall distance. So, we will see the plot like this. So, this is the Hall time is given, and this is the Hall distance is given, and if you plot, you see here we are getting the A value, that is a first constants, and we get second value B, that is the slope of this curve 0.2 divided by 10. So, x 0 A will be the 0.080 that we found, and the slope of the line, that is 0.02 r per mile, and now we have to calculate. Now, from this graph where we calculate the A, the constant, and B constant, okay, for given data by plotting the graph between total time versus round trip Hall distance x value. Now, we will calculate the h value. So, evaluation of the round trip Hall time for a site that is located 11 mile away. So, first we have to calculate round trip distance, that is x value, that will be a double of whatever the distance is given for the locations. So, 2 into 11, that is 22 mile per trip, that is round trip distance. Now, we will calculate the round trip Hall distance h equal to a plus b x, a and b we found, and we will multiply by x, that is finding round trip Hall time is 0.52 Hall per trip. Okay. So, there are few additional comments onto that, like first is the determine the time required to travel to the disposal site to the field. Time should be determined at the approximately same time the collection vehicle will be traveling to and from this to and from the unloading location. So, here you see the round trip distance we multiplied by 2, means the thought was that, simple thought was that whatever time required to travel from the location to the disposal site and whatever time required from disposal site to the same location, we thought of is the same, both will be the same, that is why we multiplied by 2, that is a one important assumption. And Hall time data collected during working hours will be include the effects of traffic congestion, weather condition, and so on. So, whatever the Hall time we calculate, that is including of all conditions like traffic conditions, weather condition or whatever the maintenance issue will come up, that is including into the halt time data. Okay. So, from this one numerical we found that how we can calculate the A and B constants, and also based on that how best we can calculate the halt time value. Now, we will go for another numerical, another problem. From that we will try to understand the how best we can design the Hall container system. So, the problem statement is the solid waste from new industrial park is to be collected on large container, that in the drop boxes, some of will be used in conjunction with stationary compactors. So, it is a mix of Hall and stationary container system. So, based on traffic studies a similar park, it is estimated that average time to drive from the garage to the first container, that is T1 value, and from the last container location to the garage, that is T2 value, is given that 15 minutes and 20 minutes respectively. So, T1 is 15 minutes and T2 is 20 minutes. And if the average time required to drive between container is 6 minutes, this is DBC value, DBC value. DBC value 6 minutes, and one way distance to the disposal site is 15.5 mile or 25 kilometer. So, it is a one way distance, but you remember that x is a round trip haul distance. So, we have to double this value, and the speed limit is given, that is 88.5 kilometer per hour or 55 mile per hour. Determine the number of containers that can be emptied per day based on 8-hour work day. This 8-hour is given, that is capital H value. Now, we will solve the problem, and again the one more value is given, the assume off-route factor W is 0.15. If it is not given also, you assume that is a 0.15. So, we will go for solution. First, we will determine the pickup time per trip, that is PHCS. PHCS is equal to PC plus UC plus DBC. Now, here DBC value is given, but PC and UC is not given. These PC and UC value will refer from the one table is given. I think you try to find the source. This is a very good book, and some of the notes also I took it from this book. This is a very good book for the reading purpose. From that, this book has given this data, where the different kind of vehicle and what could be the compaction ratio, what could be the time required to pick up loaded container and to deposit empty container. So, this is the PC plus UC value, and also is given a at site time, that is S value is also given. So, here in problem it will be given that what kind of vehicle has been used. So, here we had used the tilt frame, this is the vehicle had been used. So, we took value of PC plus UC 0.4 hour per trip, and also at site time we will take 0.133. Okay. So, suppose in exam this table will not given, but the value will be given, or otherwise this table will be given. You have to find the values based on the what kind of vehicle and what kind of collection system, whether is a Hall container system or stationary container system, because this table is given for stationary container system also. So, now this DBC is given, that is a 6 minute, that we converted in hour per minute, 0.1 hour per trip. Now, we calculate PHCS is the sum of PC plus UC plus DBC 0.5 hour per trip. Now, we determine the time per trip, that is total time required in a trip, that is TSCS, that is PSCS plus S plus A plus BX. Now, pickup time we know that 0.5 hour per trip we calculated already, and S we took it from this table 0.133 hour per trip, and A and B also I think here in problem is given time limit is 55 mile per trip. So, from that we took A value 0.016 and B value 0.018. It is possible that in exam this graph will be given, otherwise the value will be available in the exam itself, like A and B value what has to be assumed. Now, TSCS we will calculate, that is PSCS plus S plus A plus Bx. Now, here Bx we know the distance is 15.5 mile. So, that multiplied by 2, that is round trip haul distance. So, that is coming 0.12 hour per trip. Now, once I think two values we know that, one we calculate pickup time, we calculate total time required. Now, we calculate number of trips that can be emptied or that can be made per day, that is a total time available in a day divided by time required in a trip, that is ND value. So, H is given, that 8 hour work time, W we assume 0.15, T1 and T2 that is given 15 minutes, that we converted in hour 0.25 hour, T2 is given 20 minutes, that we converted in hour 0.33 hour, and STS we calculated that 1.21 hour per trip. So, therefore, ND will be 5.14 trips per day. This is the answer, number of trips per day. But you see here this is not possible, the 0.14 trips cannot be possible. So, we will assume 5 trips per day, that should be a single numerical value. And suppose here if your solution will come up, suppose 5.8, suppose if it is come 5.8, you consider is 6, assume to 6. Okay. So, is it just 5.14. So, we are assuming 5 trips per day. Now, because the trips has been reduced, theoretically we found the 0.14, but we assume numerical value 5. So, we will again determine the actual length of work day, because that 8 hour work day will not be possible. So, how much time will be remain? So, if you put it in the same equation, putting in the formula of ND, same 5 trips per day, and we will calculate the H value. So, here H is getting 7.8 hour, but actual work time is available 8 hour. So, that 0.2 hour is available. So, essentially will be the 8 hour. So, suppose what I said it in the previous class, previous slide, like when it is a 5.8, the value you assume 6. So, your time requirement will be more, that will be more than 8 hour. So, it is possible that some manpower to pay extra charges for half an hour extra work or 1 hour extra work, and you can benefit it by increasing the number of trips in a day. Now, what are the additional comments? So, your answer is 5 trips per day, that is possible with the given data. So, some additional comment for this example, where the fractional equipment or labor requirement obtain the use of large containers and reduce collection frequency should be investigated. That is also very important, the labor requirement, that will go for another one more problem we will solve for the, especially for the labor requirement or the time required in a week, the TW value also we will calculate. And if it is assumed that no off route activity occurred during the time T1 and T2, so theoretically 5.21 trips could be made if there is no off route activity. So, theoretically 5.21 trips per day could be made, but again 5 trips per day would be made in the actual operation, which I had already explained. And if I were the number of trips per day, that could be made 5.8. Suppose if it is possible, for example, it may be cost effective to pay the driver for the overtime and make the 6 trip per day, that could be possible. So, we will finish this lecture, and in this lecture we see that in the Hall container system how best we can calculate the Hall constants A and B, followed by Hall time from the graph, plotted graph, and also given data how we can calculate the number of trips per day, and we can design the time period in a work day. In a work day we can go more than 8 hours also, or we can increase the number of trips. By that we can design. This kind of example is for the one location. Similarly, we can go for the different locations, and by that way we can finalize the number of trips and how much time required. So, next lecture we will go for few more examples, where we will try to calculate the labor requirement, and also the vehicle type, vehicle size also, how best we can calculate. So, thank you.